After the presentation of the basic morphological structures, let's now describe the first nuclear elements of average mass.
During an addition on the parietal hollow of 3 pentagons or type H3, we obtain 6 new pentagons on the nuclear wall. So we have an increase of 2 mass units and 1 electric charge unit. With an addition on the hollow of 4 pentagons or type H4, we get 4 new pentagons on the external wall. But let us recall that the nuclear additions are made only with trefoils of 3 pentagons. Thus, at the level of the external wall, the addition of 4 new pentagons must be completed by the introduction of 2 internal pentagons to form a total of 2 times 3, and thus 6 new pentagons. Therefore, since it takes 6 external pentagons to have an increase in electrical charge, the addition of type H4 leads to an increase of 2 mass units without modification of electrical charge. Now with 2 additions of type H4, we obtain an increase of 3 mass units with an increase of only 1 unit of electric charge. There is therefore an addition of 8 external pentagons on the wall with an internal pentagon in order to complete the addition of 3 times 3 pentagons, and so 9 pentagons of growth. Therefore, 3 additions of type H4 are required to obtain an increase of 4 mass units and 2 units of electrical charge with the introduction of 12 new parietal pentagons without internal pentagons. Now, supplement this information concerning internal wall reinforcements, which play the role of umbrella ribbon maintaining the overall structure. Due to its strength, the dodecahedron will stiffen the nuclear wall in 2 positions. First, in tropical inclusion, as is the case for carbon-13, nitrogen-15 or oxygen-17.
It is therefore linked to the addition of type H3 with 3 internal pentagons. And in equatorial inclusion, it contains 6 internal pentagons.
Now the internal helix positioned under a hollow of 3 pentagons makes it possible to stabilize a parietal concavity. Finally, an internal pentagon also serves as a stabilizer in the position of a partition wall. It is then representative of the additions of type H4. With these few simple rules, we can now resume the description of the nuclides of average mass from the oxygen. The equatorial part of the oxygen-16 contains a hollow of 4 pentagons, which can be filled with an addition of type H4, and form the isotope 18. With 2 internal pentagons, the oxygen-18 then has a symmetrical decahedron shape, which is confirmed by a spin of 0. Note that this decahedron is the basis of decahedral morphologies. We thus have, starting from carbon-12, a first addition of type H3 which gives nitrogen-14, and then a second which gives oxygen-16. a third addition H3 can be carried out on the third tetrahedral face to give the fluorine. However, at this level of filling of the first tetrahedral layer, the last face presents a hollow, which will tend to create a blistering of the wall. Consequently, the fluorine 18 is unstable, and it is thanks to an internal helix that this expansive tendency is blocked. There is therefore only one stable isotope for fluorine, this isotope 19 manifesting its dissymmetry by a spin of 1/2. Beyond fluorine, neon 20 is the representative of the first complete tetrahedral layer. But, in addition to the tetrahedral form, neon 20 also has an isomass with octahedral morphology. Thus, taking oxygen 16 as the base, the 2-3 pentagons hollows, which are opposite to the 4 pentagons hollow, can be filled with 2 H3 type additions. With a filled dodecahedron in tropical insertion, neon 21 is obtained. And with 2 filled dodecahedrons, we have neon 22. It can thus be observed that the neon 21 is asymmetrical while the neon 20 and 22 are symmetrical in dodecahedral and octahedral bases. This is confirmed by their spin because the neons 20 and 22 have a spin of 0 while neon 21 has a spin of plus or minus 1/2. On reaching the sodium, we begin the second tetrahedral layer. With 2 additions of type H4 on the complete layer of the neon, and thus 8 new external pentagons, we obtain an additional electric charge of 1 3 units of mass with an internal pentagon. Since the only stable and balanced morphology corresponds to 2 additions H4 in opposition, this nuclide exhibits a non-zero spin due to the residual internal pentagon. As for magnesium, it has 3 stable isotopes. Magnesium 24 is the representative of the dodecahedral morphology of which it forms the first layer. Its perfectly symmetrical structure is confirmed by a spin of 0. With 3 additions of type H4 we arrive at the magnesium 25, which represents the half part of the second layer on the tetrahedral base. Note that an addition of type H3 is necessary at the opposite tip to balance the nuclear structure. This gives a non-zero spin to magnesium 25. Now let us introduce the addition H6, which fills a hollow of 6 pentagons. It is therefore a group of twice 8 pentagons that comes to cluster in this hollow. For an addition of type H6, we thus obtain a growth of 10 external pentagons with 2 internal pentagons. That is to say, a supplement of 1 unit of electric charge, and of 4 units of mass. Taking the hexahedral base of nitrogen, the first H6 addition gives the oxygen 18, which we have already seen in the decahedral base. The second addition H6 could give a neon isotope that is unstable because unbalanced without leaving room for a parietal reinforcement.
On the other hand, the third addition H6 corresponds to the first uncompleted balanced hexahedral layer, which is an isomass of magnesium-24 without internal pentagon, as well as magnesium-26 with 6 internal pentagons.
The next element is aluminum. It also has a single stable isotope with a mass of 27 units. In tetrahedral morphology, it presents 5 additions of type H4 with a residual internal pentagon, which is destabilizing. But in hexahedral morphology, from magnesium, we obtain 2 additions H4 with a residual pentagon in opposition, which is then stabilizer. It's why the nuclear asymmetry of aluminum-27 has a non-zero spin. Now, with 14 units of electric charge, we have the silicon. In tetrahedral morphology, silicon-28 represents the third complete layer. Now, in hexahedral morphology, we have silicon-30 with 4 additions of type H4, which is balanced with 2 internal pentagons. On the other hand, the hexahedral base silicon-29 is equilibrated with an internal trefoil. This explains why balanced nuclides such as silicon-28 and silicon-30 have a null spin while silicon-29 is asymmetric. Then, in order to present the phosphorus, let us describe the addition, which covers a hollow of 12 pentagons with 18 new pentagons. Finally, an addition of 6 external pentagons is then obtained. And consequently, the result is an increase of 1 unit of electric charge and of 2 units of mass. In these conditions, the phosphorus is then the first nuclide to have an H12 addition on the third tetrahedral layer. However, an internal helix makes it possible to retain the wall. Consequently, phosphorus 31 is the only stable isotope of this element with a non-null spin.